Welcome to our video on factoring. In order to factor an expression, you want to break it down into multiplication parts, is what factoring means. So you need to, whatever you're factoring, whether it's a polynomial or anything else, the idea is to turn it into something times something times something times something. And then also division, if you have a fraction, that is still technically something times something. It's just times 1 over whatever the bottom part of the fraction is, okay? Now there are two main ways to factor. You can factor using areas, which is really quite silly, and I'm going to go through that really quickly. It's really just a visual tool, and it is not at all practical to use on a regular basis, and instead we should use the normal way to factor, which we'll see second. All right, so this next example is going to show you how to factor a polynomial with a subtraction. Here's our first example. X squared plus 2x minus 3. Here's x squared, here's 2x. Here's the 3 that we have to take away from it. So if we line our pieces up here and then kind of take these 3 pieces away, and then take this little piece and move it over here, we can see that all of these pieces have the same height as x minus 1, right? Because these used to all be a height of x, and now they're x minus 1. And then the total distance across, this was x plus 2, and then we added that third, so x plus 3 minus, and x times x minus 1, sorry. And that's how we would factor that one. All right, what about the second one? To remind ourselves, it's x squared plus 5x plus 8. Here's all our pieces. We can try and arrange it this way, but we get a leftover. We can try and arrange it this way, but we get a leftover. And this tells us that this thing is not factorable. Okay, so it is a valid technique, but it's not one that I would really recommend trying to learn because it's really just a visual tool. It's not something you want to learn or try on a day-to-day basis. Instead, you want to factor the old-fashioned way, which is put down some parentheses, fill in what you know has to be there, and then move around whatever stuff can change until you find a combination that works. Basically, it's a guess and check game, and I know that sounds like that's a lot less efficient than the graphical, rectangle way, but it really does become pretty quick once you practice it. So when you are given any polynomial, you give yourself two, well, I shouldn't say any polynomial. When you're given a quadratic, this is really used for factoring quadratics, or what are called trinomials, something with 3 pieces where you have a squared term, a linear term, and a constant term. Then you're going to get 2 factors in parentheses. And you know that the x terms have to multiply to whatever x squared is. And since there's a 1 here, then the only way for that to happen is an x and x. If there was a 2 here, you would have to have a 2x and an x. If there was a 4 here, you could either have a 4 and a 1 or a 2 and a 2. So you can see that you get a lot of options as this number becomes anything other than 1. So your first goal is to always turn that into a 1 if you can. So for instance, if you have a quadratic and you set it equal to 0 and you're trying to solve for the 0, so you need to factor it now, you might as well divide by whatever this number is if you can, because if you just divide 0 by it, it's still 0. But if there was a 4 here, if this is 4x squared, 3x, and 2, and you divide everything by 4, all of a sudden you'd have fractions, and you really can't do this technique with fractions. So you can only divide that number out when you can divide them all out by that number. Okay, so just keep that in mind, that if you can reduce it, simplify it by factoring that thing out, by all means do it. Otherwise, you're kind of stuck with it. And then the second thing we know is that the 2 constant terms have to multiply to whatever the constant is. So just like these two had to be x and x, there's no other way to get x squared. The only way to get 2 is 2 times 1. And because x and x are the same, rearranging these doesn't matter. Right? If this was a 2 here and we had a 2x and a 1, then we would know it would either be 2x and a 2 and an x and a 1, or it could be 2x and a 1 and the x and the 2, meaning these two things could swap places if these two x's had different coefficients. And since they're the same, rearranging them doesn't give us a new outcome. And this is our only unique way to. And since these are really our only options, now the only thing left is, what are these symbols? They're either going to be pluses or minuses. Because this is a plus, we know that both of the symbols have to be the same. They either have to both be positive or both be negative, right? Because the only way to get a positive number is a negative times a negative or a positive times a positive. So if this was a negative, we would know it'd be alternate signs, either a plus here and a minus here or vice versa. So because this is a plus, we know they're both pluses or they're both minuses. Because this is a plus, we know the only way for these things to add, right? Because we get the middle piece by doing these two middle ones and these two outer ones. So this is going to give me 2x, this is going to give me 1x, and the only way to get 3 is to add those two together. So we know it has to be plus and plus. And that's basically how you factor these things. Right? So we know it's got to be plus 2 and plus 1. You're kind of reverse foiling, so to speak. All right, let's look at another example. We've got that 2 sitting in front of here, and we would love to be able to factor it out, but we can't because not everything is even. So we're stuck with it. So we know it's got to be 2x and 1. Now 6 factors into 1 and 6 and 2 and 3. But because we've got a 2x and an x, rearrangement matters, right? If we put a 6 here and a 1 here versus a 1 here and a 6 here, it's the same two numbers, but you see how this gives us two different sets of factors. So we also have to take 2 and 3 and 3 and 2, and this now gives us 4 possibilities. And that might seem like a lot, but you can check it really quick because all you have to do is check the insides, right? Again, because this is a plus and this is a plus, we know everything is pluses. And so this 7x has to come from the middle two plus the outer two. So this would be 6 plus 2 is 8. That doesn't work. 1 plus 12. That doesn't work. 2 plus 6. That doesn't work. 3 plus 4. And ta-da, the last one is the one that gives us that inner product that we're looking for. And that's basically how you factor these things. It's just trial and error. You set up the two x terms and the two constant terms based on what you have, and then you figure out which pairings work. All right, that idea of common factoring I wanted to talk about really quick. When you have something that all have something in common, you pull the 5 out, right, because they're both divisible by 5. But then you notice they're also both divisible by x. So why not take both of those pieces out and get 5x and then see what you're left over with, x plus 2, and that's now completely factored. And if there was a constant term, you could obviously only pull out a constant, but you would pull it out only if they all had the same thing in common, right? If they were all divisible by 5, then you would reduce that down, and then you would have just x squared. And that's basically all we care about for factoring. Unless there are specific, let's say, perfect examples. So the technique we just learned, we can use that for all quadratics, all trinomials. But we also want to keep an eye on kind of these special things. When we see x squared minus 36, we should recognize that as what's called a difference of squares. This is x squared minus 6 squared. And when we have a squared minus b squared, we know it factors to a minus b, a plus b. And that's just a pattern. And that's really something you're going to want to memorize. When you look at this, you go, okay, well, they have a 2 in common, so I'm going to factor the 2 out, and then I'm left with this. And then that, again, is a difference of squares, because you see how this is just 2x times 2x, and this is 5 times 5. So here's my difference of squares, and then that common term is still there. So that helps us factor this piece. All right, let's look at the third one and see about this. Again, we look at them and go, all right, they're all divisible by 6, so I'm going to take out the 6, and now I'm left with this. And this is a x to the fourth and x squared and a constant. So this is what I call a quadratic in disguise, right? It's still a trinomial, and it still really is a quadratic term. It's just in disguise, because a true quadratic is something that has a constant term, and then it has something with a variable, and then something with that variable squared. Now, normally that variable is just x, and then this piece becomes x squared. But if that variable piece is x squared, then when you square it, x squared squared is x to the fourth, right? So you see how it still follows the rule of a quadratic. You have a linear term with no power of x, then you have a term with a power of x, then you have a third term with that power squared. And that's technically still a quadratic. It's just a quadratic in disguise. It's not a true quadratic. By rules, a quadratic has to be of power of 2, but it's a pseudo quadratic. And if you just think of it as a quadratic in disguise, you can realize that you can use the exact same techniques. We can factor a quadratic by taking this thing and breaking it up into two pieces. And instead of x and x, it's got to be x squared and x squared. Then we take the constant term and we put it into two pieces, and it's got to be either a 2 and a 2 or a 4 and a 1. By trial and error, because this is a negative, and we know we have to have a negative and a positive or vice versa, right? By trial and error, we see that this is the one that works because this gives us negative 4 plus 1, so that gives us negative 3x squared. So we were able to figure this one out by the same trial and error method. Now that we're here, we look at both of these two things and say, can we factor them, right? They're not trinomials, so we can't factor them with, a set of two parentheses, but maybe they're a perfect square, difference of perfect squares. Well, this one isn't because it's x squared plus 1. If it was minus 1, that would have been awesome. Then we could add x plus 1, x minus 1, but that doesn't work. But this one is a difference of perfect squares, right? X squared minus 4, so there's my x minus 2, x plus 2, and then this thing doesn't factor at all. And we have now completely factored this big ugly thing, and really all we did was use the same techniques. Factoring a quadratic, a trinomial, factoring out a common term, i.e. a constant, and then factoring a difference of squares. So those are the three biggies to learn in this video. And that's it.